A ratio is a comparison of two things, but it's also important to take a look at exactly what are the two things that you're comparing. First off, in a group of students working in a booth to support the community center, and the amount of time that each student works is in a ratio according to their ages. This is something we talked about in class before. We'll get to that in a moment. So we see Abby is 16 years old, Kaya is 12 years old. So let's write that down. We know Abby is 16, and we know Kaya is 12. If you write it down as a ratio of 16 to 12, one way of translating this is saying for every 16 minutes that Abby gets to work, Kaya gets to work 12 minutes. Now, this is pretty a useful thing, but whenever we have ratios, one of the best things we want to do is to simplify them. Because when we simplify them, they're often easier to work with, and the numbers aren't so big. One way that you can simplify them is to multiply or divide by the same number. In this case, simplification usually requires dividing by the greatest common factor. If you want to take a look, 16 and 12, the greatest common factor is equal to 4. If we divide this by 4, we can see, divide by 4, we can write a new ratio, 4 to 3, and this means two things actually. The first of which is that for every 4 years that Abby is alive, Kaya is alive for 3. But because they also get to work as according to the ratio, this also means that for every 4 minutes that Abby gets to work, Kaya gets to work 3 minutes. Now, you take a look at this. If Abby works 120 minutes, we can see that we can scale up from 4 to 120. In this case, 120 divided by 4 would be equal to 30. So by scaling up into multiplying by 30, we can do the same thing on the other side. And we can see that if Abby was to work 120 minutes, then Kaya would get to work 90 minutes. So even though we started off by taking a look at their ages, it's really another way of saying that's also how much time they get to work. If you take a look at the second question over here, Jacob is 14, Matthew is 10. 14 years old and 10 years old. Once again, they're working as a ratio of their ages, so this means for every 14 minutes that Jacob gets to work, Matthew gets to work 10. Let's try to simplify this. Take a second. What do you think is the greatest common factor? In this case, the greatest common factor is equal to 2. So in this case, we can also say for every 7 minutes that Jacob gets to work, Matthew gets to work 5 minutes. Now the tricky thing over here is that they work 120 minutes together. So that means you would have to add each of the individual parts to figure out what the whole is. 7 plus 5, not 12. Oh, actually, it is 12. 7 plus 5 is equal to 12. That means every time Jacob works 7, Matthew works 5, they're really working 12 minutes together. If they're working 120 minutes together, it's pretty easy to see 10 is the factor that you have to multiply by to get 120. Follow the same thing on each of the individual parts, and you can see 70 to 50, add them up, you will still get 120. It's in the exact same ratio. If you want to double check it, 14 times 5 is 70, and 10 times 5 is equal to 50. And finally, Michael and Hannah work together. Hannah works 160, Michael works 100. Once again, 160 to 100. And now we're not talking about the years. We start off with the minutes. We can say, how old could each of them be? One possible answer is 160 years old and 100 years old, but that's pretty unrealistic. Now remember, if you want to write equivalent ratios, we can multiply and divide by the same number. Oftentimes you want to start off with 2. 160 divided by 2 is equal to 80. And 100 divided by 2 is equal to 50. So now we have a real plausible answer. They could be 80 and 50 years old, respectively. Divide by 2, excuse me. Now, you could do it again or divide by other common factors. For example, instead of saying divide by 2, we could have also tried divide by 4. If we divide by 4 instead, we can see 40 and 25 would also be an acceptable answer in this case.